Hello everyone and welcome back. So this will be a very short video and I'm going to talk about a particular exercise that comes next in the text. And this is exercise number 2.34. So we are given a task to calculate the square root and logarithm of the matrix. So whenever you are given a task to calculate square root and logarithm, you think in terms of numbers, right? So you have a number, let's say a, and you have to calculate the square root of it, or you have to calculate the log of this number. And definitely you also check this positive semi-definite thing. If you want to find the real number, then this a has to be greater or equal 0. And if you want to find the log, then it has to be non-negative. So these are the things you are thinking whenever you are calculating square root and logarithm in terms of numbers. But what about matrix? So we are told to calculate the square root and logarithm of the matrix. So how this is possible? So remember in the last video or last two videos, we talked about this spectral decomposition. If A is a normal operator, then it can be written in terms of this spectral decomposition, and you can also define a function of the operator like this. We have defined this uh, function for operator, and we are taking coefficients function of A and like this. So we will be using these two facts here to calculate the square root and logarithm. The square root of the matrix function of the matrix will be square root function of the matrix will be like this. So this will be the function here, and for calculating the logarithm, our function will be this, right? Just like we used to calculate the exponent of the operator in the last video. So at first we have to calculate the eigenvalues. And how do we calculate the eigenvalue? We use this thing, right? We use this characteristic equation. So we'll get eigenvalues, and for each eigenvalue we'll be getting eigenkets, right? We can also, if we get the eigenvalue, then we can calculate the corresponding eigenkets, right? So now we will be calculating these coefficients, and use these coefficients to expand this expression. So these are our functions, and just following the same procedure that we used in the example that is given in the book, we can calculate the square root and the logarithm. And also after calculating the eigenvalues, you can check this semi-definiteness or definiteness of the eigenvalues. But I hope you'll see that it satisfies this condition. So that concludes the video here. And lastly, I want to say again, these videos are part of the discussion. In no way I'm going to teach anyone anything. So we are supposed to make study discussion, and it was inconvenient for me to fix a date and make a longer time to conduct the study session. So that's why I'm making these short videos, and you can watch these videos at your suitable time. And then later, after making several videos, we can sit for a discussion. And personally, I see that in this study group, there are a lot of people, around 20 people now. And personally, I know only one people, and who is doing his PhD in physics. but I have seen the other messages, and there might be some other people, some other students who are sophomore bachelor student. So whenever I'm making this discussion or I'm just talking, I just think about those people who are new, uh, uh, and they need some basic discussions. So I'm just considering those people. But if you find these discussions are too slow, then you can go fast. And uh, and also I consider the responsibility to study is individual, right? So individually, every person is responsible for their studies. So considering all of these, I'm making these videos, and there might be mistakes, there might be some sloppy languages, and which can mislead you. And look, again, these topics are taught by the professors at the university level. So if I'm a master's student, and I'm making these videos to express or to explain, is kind of ridiculous. But even though we are in a study group and we have to make our own contributions, so these videos are part of those contributions. In no way I'm not going to teach anyone anything. So see you later.